Hi friends, in this video I will explain cyclic redundancy check for 7 marks. So this cyclic redundancy checks concept comes under the cyclic codes. Cyclic codes are linear blocks of codes in which if a code word is clinically shifted or rotated the result to another code word. For example, if 101100 is a code word and if we cyclically left shift, then what it will be performed onto the 01110001 left shift, just a shifting of one bit to left side, then it will becomes a code word and also the code word. In this case, if we call the bits in the first word A0 to A6 and the bits in the second word B0 to B6, we can shift the bits by using the following: B1 is equal to A0, B2 is equal to A1, B3 is equal to A2, B4 is equal to A3, B5 is equal to A4, B6 is equal to A6, B0 is equal to A6. So this is the representation of cyclic redundancy check, and then generator, and then the remainder or maybe redundancy has been added, and the same thing however we had discussed in the previous thing, same thing it has been present, but here extra bits it has been present. So below table shows the CRC code for from 0 to the 50. In the encoder, the data word has a k bits, the code word has a n bits. The size of one data word is augmented by adding n minus k, here 0 to the right hand side of a word. The n bit result is fed into the generator. So generator uses the divisor of size n minus k plus 1, here 4, predefined and agreed upon. The generator divides the augmented data word by the divisor by means of modulo 2 division. The quotient of the division is discarded. The remainder is appended to the data word to create the code word. The decoder receives the possibly corrupted code word. A copy of all n bit is fed to the checker, which is a replica of the generator. So these the steps we will see in the whenever we perform the calculation. The remainder produced by the checker is a syndrome n minus k, here 3 bits, which is fed to the decision logic analyzer. The analyzer has a simple function. If the syndrome bits are all as the 4 leftmost bit of the code word are accepted as the data words, interpret as no zeros, no errors, otherwise the 4 bits are discarded. Yes, here we can see encoder. The encoder takes the data word and augments it with the n minus k number of zeros. It then divides the augmented data words by the divisor. So data word which will be the 10011, and then the divisor which will be the 1011. So we have to perform onto the extra operation for this. So how to perform this one? So we will be having the data word it is present and then divisor it is present. So we need to write this the table 1011, and then this is the the data word 1001, and then by the definition we need to add onto the divisor minus 1 zeros to the data word. So here 4 length it is a 4, and then 4 minus 1 it is a 3. So 30 it has been added to the data word, and then we need to perform onto the encoding. So first we need to check whether whatever the first number we need to check here, if 1 it is present, then we need to write the quotient 1, and then we should multiply by this 1. I will be writing a quotient, and then 1 0 1 1, and then now we will perform the exclusive OR operation. 1 1 it is 0, 0 1 1, 0 0 0, and then the remaining bit I will leave here, and then first I will take the rightmost bit 0, and then here the first bit it is 0, I will write the quotient 0, and then 0 multiplied by this 0 only. Then we have to perform onto the XOR 0 0 0 0 0 0 1 0 1. So next I will take remaining bit, this 0 I will take the carry. So and then here what is the first bit 1, so next I will write a 1 here, and then 1 should be multiplied by 1 0 1 1 1 0 1 1. Now we will perform the XOR operation 0 1 1 0 1 1 0 0 0, right? So and then remaining bit is a 0. I will take here. So and then first bit is 0. I will write a 0 here, and then 0 multiplied with this 0 only, 0 0 0 0. Next I will perform the XOR operation 0 0 0 1 0 1 1 0 1. I have got the 1110 as a remainder. So in the during calculation we have added, and the n-1 divisor bits it has been added. So once upon we have performing onto the encoding, so this remainder we have got, and then I need to pass this data word plus whatever the remainder I have got it, so that it has been passed to the unreliable channel, so that it will become the code word. So 1001 is the data word, and then remainder is the 110, so that it has been added, that it will pass. So next, in the decoder, the code word can change during transmission. If the decoder does not the same division process as the encoder, the remainder of the division is the syndrome. If the syndrome is all zeros, then there is no error. The data word is separated from a received code word and accepted. Otherwise, everything is discarded. So here there are two calculations are present. One it is without the syndrome, and then another one is with the syndrome. So whatever the data code word we have received 1001 and then remainder 110, we need to perform onto the reverse operation at the decoder. So same thing, divisor 1011, and then we are going to writing onto the code word. So and then we will perform. Okay, here first bit is 1. I will write the quotient 1, and then that should be multiplied by 1011 1011. So 11 perform the XOR operation 110 0111 000. So next I will take the first the bit, so which is going to 1, and then here 0 it is present. I will write the quotient 0. It should multiply here 0 0 0 0 0. I will write the same thing 0 0 0 0, and then 101 0 0 0 1 0 1. So next I will take the remaining bit 1 1. I will take here, and then here first bit it will be 1, and then I will write 1 here, and then 1 multiplied by this 1 0 1 1. Next I will perform the XOR operation 1 0 1 1 0 1 1 0 0 0 0. So next I will take the last the bit 0. So and then the first bit is 0. I will write 0 0 multiplied by this 0 0 0 0. So then I will perform the XOR operation 0 0 0 0 0 0 0 0 0, and then finally I got the remainder 0, which is going to indicate in syndrome it is 0. Then it will be accepted what this the data word it has been accepted. Now we will see if there is any modification during transmission. We will check whether the syndrome it will come 0 or not. The error it has been syndrome it has been present in this. Here we will be having the code word it is altered in transmission 100110. Now we will perform the same operation. We will write the same code word 100110, and then we will perform the XOR operations or maybe a decoder operation. So first bit it will be 1, so I will write 1 here in the quotient, and then it will be multiplied 1011 1011 011 011 000 0. So next first bit it will be 0. I will write 0, and then it should be multiplied by anything, it will be 0. So and then 101 101 101. So next I will take the next bit 1 here, and then I will first bit here it will be 1, and then I will write 1 here, and then it should be multiplied by 1011 1011 110 110 101. Next I will take a remaining bit 0, and then first bit it will be 1. I will write 1 here, and then multiply by that 1011 011 011 000 110, and then finally I have got the remainder 011, which means what a syndrome I am getting other than 0. Then at the time it is going to discards the data word, which means what during transmission any the bits it has been changed or maybe altered, then we will not get the syndrome bit as a 0. So which means what if 0 comes at the time we need to confirm that it is not altered. other than 0 comes, then it will be altered.